Hello friends, welcome to Intuites.
Let's begin the class.
Yeah, Samir, graph I work in PyCharm, but I couldn't get the pie chart or bar chart.
Well, in PyCharm,
Yes, should I
what is
add?
the
Yeah,
any
yeah.
error?
Yes, I will send in the group. Shall I?
Yeah, you can do it. I will recheck after the class.
Oh, okay, Samir.
Okay. So in the last class, we have discussed the database connectivity from the Python, right? And we have written some 3-4 lines how to connect to a on-prem database like SQL Server, Oracle, or whatever. And we take an example of a SQL Server, and we written some imported one SQL comment. Then based on that, we create the engine and just connect it, and we just run a simple query from there from my connection, and it worked. Okay, right? That's it. We're done. Right? Now let's do the main thing, right? So what I will do in this class today is that I have that two txt file yesterday I given you, right? I think orders txt and returns txt, right? Those are working for you.
Yes, we can download.
Okay, and it's working. Download. I'm not saying.
Yes, Samir.
Right.
Those are working.
So what I'm do, I will read that file, the CSV file, and we'll do some transformation, basic transformation we'll do, and finally I will load this data into the database table. Okay, so that's what we will do it in this class today. Okay, and this will be last class for the Python, and then I will start the big data for you. Okay, so let's understand how I can do it. Still, I'm audible, right? Properly. Whenever you are saying that there's no.
Yes. Yes, we can hear.
Okay, let's create first function called extract. Okay, then I will say in this extract function, I will read both the files. Okay, so my files are available inside my PyCharm projects itself only. So the order txt and the return txt. And my file, the Python file also is available on the same folder. In that case, we don't need to give the complete path of the file. Okay, if both are in the same location. So what I will do here, let's create a df underscore orders, which will be my panda dot read csv. Because txt file also will run through the csv only. And then I will say here orders.txt. Orders.txt. Okay, then finally I will create another frame which will returns equals to pd dot read underscore csv, and the file would be returns.txt. Okay, and finally I will return this both at one cost. So I'll return whatever there in this data frame and whatever there in this data. Okay, any questions on this function? Simple, right? I done it. And this is the first function which I have written. Okay, you will just read it and you will just return. That's it. Now the next function will be the transform. In this transform, I want this both, whatever the data frame I have created, I want to pass it as a parameter. Okay, so let's say df and df1. This is a data frame objects which I want to pass on. Okay, fun, and I will say at any time you are not able to understand, do let me know. Okay. Now I will create a data frame here inside the transform, and I want to combine these two data, this df order and df returns. What transformation I need to use? I want to combine these two orders and the returns. Which transformation I should use?
Dot merge.
Mm-hmm.
Dot merge.
Okay, merge. So merge from where?
Orders df
Merge.
underscore.
Now merge is a methods of what? Means what I need to put in this case. Pandas dot merge, right?
Yeah, pd
Pandas merge. Okay, can go ahead. What is the syntax for the merge?
df underscore orders.
Mm-hmm.
How df underscore returns. How
Let's go
left
for inner.
or inner. Yeah.
Let's go for this. Now the next one, left underscore on, right? Equals to. Let me check the files.
Order right.
One is order ID. Then right
Right
on
on.
equals to this order ID. Okay, see, in this case, the left table have order ID, order underscore ID. The right table have order space ID. If in any file, two files have the same name, like suppose let's check the first file will be order underscore ID, the right file of the order underscore ID, then another syntax will work here. That is like, we can say directly like this, on. If that's it, give the column, it will work because both the files have the same name. If both are different, then you need to write on the left one and right one. Okay, now I'll say return. Let's run this. Now I will first I'll do the load part after this. Just try and understand. Now I say calling test. It is giving me both the data, right? So this is up to here. It is giving me this one, and this is the one. Correct? So this part is if I run the extract up to here, this is the order data and this is the return data. Right? Correct, right? Yes or no?
Yes.
Are you guys following me?
Yes.
Or lost somewhere? So now what I will do is since it is written in two data frames, I will store in one of the variables. It could be any, it could be anything A, B, C, D, whatever. Okay, so we can take OR, comma, RN. Or no, order, comma, RN equals. So what will happen? So whatever the data frame it will capture, it will return. One will be stored in ORD and one will be stored in RN. Right? Now if I say ORD, it will give you the ORD order data frame. And if I return RN, it will give you the return. Make sense? Does that make sense?
Yes.
Now, this two data frame I will pass as a parameter to the transform. Okay? I will say transform ORD, RN. So what will happen? This will become the DF1 and this will become DF2. Okay. Name error. Yes, there is will be a name error. Let's see. Here we need to give. I will change it this parameter to make sure that we are passing on the DF orders only. So let them make the parameter name also the same so that it will be easier to understand. Okay, now I think it's good. I think so. All should be the same name. Passed on here this one. And let me run this. I think we need to pass on the name also the same one. Now it should work. So all the names should be same. Sorry. Now if you see here, when I'm like running the transform, you see this is join. So up to profit, it is the order data, okay, and the order ID and your return regions are from your return date. So this is the data we have. Okay, make sense? Any questions to here?
Right. So the question here, right? So you want to use always the same variable for everywhere, or if you change the
No.
variable,
Yeah.
we cannot change the variable.
Because why it is because this is a data frame. And when it
Okay.
is returning, it is assigning with that name only. DF orders
Okay.
means it will contain the order. So that's what we are continuing with it. That's what we are.
Okay. So okay, can you explain this line number 13 alone? Okay, just because I get little confused. This 13.
Nothing. So if you see the extract function, right?
Mm.
So extract function is written two data frames.
Oh, you are storing two data frames output.
Yeah, this is
Okay.
the output into the two variable. That's
Okay. Okay. So as you said in the line number 6, so if we are using the same variable, we can use on order ID equal to order underscore ID, same if it is the same variable,
no. If
right?
the column names are same
Column
in
that's right.
both,
If a column name is the same in the both the table, so you can use comma on and then order ID underscore
that's it.
equal to.
That's it.
Okay.
That's it.
We cannot,
Yeah.
if there is a different name also, different name we cannot use that way.
No. If there is different, we need to set this way: left on, right on.
Left arm. Because generally SQL we can use the same, even though if the different name, right? We can join. Okay, that way.
No. In the SQL also, we need to provide right order ID equals
Yeah,
order
we
ID.
can order ID equal to order ID, but okay,
No.
but we can join with that different if order underscore ID or under order without underscore ID also if the we are
No, we are doing
joining
it.
the same. Yeah.
We are also doing it. In this first table, it is order underscore ID. In the right table, you have order space ID. We are doing it. But what I'm
No.
saying, if both the
Instead of
tables have the same column, then no need to specify left on, right on. One column
left
is
and right.
enough. It will consider that as a joining condition
Joining
immediately.
condition. So the same way, okay, you are using inner the same way. If you want to use the left out or left join, we can use the left and right and all those things, right?
Yeah. This one I think I explained right
No, I
in the
was not.
class.
I'm still like yeah, I was not there, right? So I'm still like not completed the video watching. Still, I'm watching the video. That's
Oh,
why. Okay,
okay.
that's a small clarification. Okay, got
Okay,
it.
no problem.
Thanks. Thanks, Samir.
Okay. Yeah.
So
So,
Samir, one doubt. This is purely to show that using SQL Alchemy we can do SQL things using pandas. The same.
mm,
It is just that,
mm,
right? Nothing more.
yeah,
Yeah.
yeah, correct. That's correct.
Okay. Because whatever we did, all these things is joins only with
Yeah.
pandas.
Now we'll use the SQL Alchemy to load it.
Okay. Got it.
Because the SQL Alchemy you will use to create the connections to the database. That is the most important thing. After that, we can do anything on the data frame and we can write it to the database through the SQL Alchemy connection, because connection object is very important here. This part where you want to write it or where you want to read it. Suppose you or I want to read it from data. Number 3, I have written select star from sales order. Where
Okay.
connection?
Got it. Uh-huh.
The connection is nothing but my all the connections I have defined. Okay. Now the last part we have done it everything. Now let's load this. So I will take. So it is returning the DF. Okay. So it is returning the DF. I'll take the same name. Transfer. It's returning the DF. Now here I will need to say DF dot to underscore SQL. If you want to write it to a SQL to a database, then you need to use DF dot to underscore SQL. Okay, like that. You see, the saying read SQL query. If you want to say read it. When you are writing back to the SQL, you need to say DF dot to SQL. Now here I am saying on table I'm just writing orders, and I will say anyway you need to give in the connection. Now thing is this table will be created where that connection I need to provide like this. So con is the parameter name which will never change. It will be con only. This parameter con1 you can put a b c d e f g h whatever doesn't matter. So this con. Just for understanding purpose, I am giving CONN. That could be X, Y, Z. But the first parameter, which you are saying as CON, it is fixed. It's a fixed parameter for the SQL Alchemy. Got it? You no need to don't get confused here. I'm repeating one more time. The first parameter CON is a parameter of the SQL Alchemy equals to the connection which you created. That could be X, Y, Z or DB1, whatever. If that makes sense, to everybody? Hello?
Yes.
Don't
Yes.
get confused. Okay. Now, after this, in SQL Server normally we will not commit anything. Like suppose you are writing something, it will give you the data. If you are selecting something, it will give you the data. It will not lost. But from the pandas, when you are writing back to the database, no, you have to commit that. In the sense, we need to save. Otherwise, what happens is if you are not committing because you are doing from the pandas or Python to the SQL, once the connection got closed, or suppose you terminate your Python session, so in the database, whatever is stored, will sometimes it will be lost and sometimes it will get locked. You will not able to read it because the connections you are not saving it proper. So that is the one point. It's an extra in pandas when you are writing the data from pandas to the database. So for that, you need to use a statement called pon.commit. That's it. Okay, now let me run this and let me run one by one again, all the data. So this is the first one I need to run it. Okay, let me run this. So this will return and it will give you the both the data into the data frame. Then this one, the transform one, it is giving me. Then finally I will say load. Now just think and tell me in the load DF, I'm not running yet. So we are saying that the whatever the data is coming from this transform. So it is a combination of order ID, order tail, customer name, city, category, product ID, sales, profit, order ID, return region. These are the 8, 9 columns or 10 columns data we have on the data. That we want to load it to the database with a new table called orders.merge. But in my database, which database I am putting SQL demo. In my SQL demo database, let me go there and I don't have any table called orders underscore merge. What do you think it will happen if I run that? I don't have anything. Okay. What do you think? What's your thought process is going on here?
It
If
will
I need to.
create a new table called order underscore merge.
Okay. And what about others? Just put a thought guys. Doesn't matter what exactly is right or wrong.
I'm thinking, but because the table is not created, right? There may
Mm-hmm.
chances of the error because the structure is not there.
Mm-hmm. What about others? So there are two questions, two good answers is coming. One is saying that it will create a new table. One is saying that the data frame is or the structure is not there. It will throw in. Right? So let's run this and see. Okay, name error is coming. 1 second. This is not the error from our side. sorry, I need to store this data into data frame first. Really sorry. So whatever it is returning, I need to store in a database, sorry, in a data frame. Yeah, what happened? Okay, maybe. Okay, now that is run. Now I want to load it. Yeah, to load now. Some has no attribute but commit. How? Just give me a second, guys. Commit, prepare, commit. I don't have a commit here. Is it? Leave it over the commit. We'll see. Maybe some pandas version got changed now. It is different. Let's load it. Still, it is. Oh, auditor must already exist. How? 1 second, guys. This is very different. First time it ran, or maybe it was throwing an error and finally it created, I think. Uh, oh no, which time it got created. Somehow it got created.
Samit, can you drop and then recreate that one? Execute the
Yeah,
drop the table.
yeah, yeah. I'll do one thing. Let me drop this. That's that. Just refresh it. So there will be no, no merge tables there. Okay. Now let's run this. Run this from extract. Okay. Extract it, transform it, then finally load it. Some attribute error is coming. I don't know for what reason. I'm not using the commit. Oh, okay. So after removing this, I didn't run this. Okay, let me just do one. Again, I think it will be calculated, hopefully. Yeah. So let me drop. I understood. So drop table. Again, I'm doing it. I got it.
Also, I mean, we can give this command, the drop table command, in that before, like after the connection.
That is, yeah, you can do that. That's your job. That is
Yeah.
doing best. So I'm just running this again, the load df actually. Now I'm returning this. Now I'm returning the load data. Okay. Yeah, there is no error now. And there will be a table got created. Hopefully. Extra from order sort much. Yes, absolutely got created. Okay. So this is the way you can load the data into your database. Okay, just give me a second. I need to put my headphone charge. Okay. Now, one thing here, the problem. The first problem, what you are seeing on the table, when you see on the SQL server, can you just tell me?
We have the same column with same values, two columns, order underscore
Yeah.
ID and order ID.
Because this is coming from the pandas data frame, it is in a habit of putting an index column, right? That is the obvious case. It will give you index. And we have already a row number already. So I don't require this index at least. Okay, this is an extra column for me. Okay. Correct now. So for that, let's see the parameter. But before to that, if you want to load again, suppose I have already a table exist on the order merge, and if I want to load again, so I'm running the 28 line. So what should happen? What do you think? It will throw an error, or it will append, or it will override, or it will drop the table, truncate the table. It will do what exactly will happen if I load
It
again?
will overwrite.
It will override. Okay. What are others?
It will create another set of the record.
It will throw an error.
Same record will be.
No, it will throw an error. It will throw an error saying that this is already exist. Okay, because it is not able to identify that because already data is there. So for that, couple of parameters we need to set up while we are writing this. So after this, the connection part, you need to say first of all I want to remove this index column. Okay, I don't require this index column. So first of all, I need to say index equals to, sorry, not capital, index equals to false. This is the first parameter I need to define. Okay, so that the index column will be goes out. Second one is that suppose what are exactly two things here, two ways to handle it. So first of all, you want to say that whether if the table exists, what exactly you want to do? Whether you want to replace it or you want to append it. Okay, so there is a parameter called if underscore exists. Okay, equals to there are two parameters will come, either replace it. So what will replace it will happen? It will just truncate the table, all the records, and it will finally load the table again. And if you instead of replace, if you say append, then it will be override. Multiple records will be getting inserted to the table. Let's run this. Now previously line number 29 was throwing an error. Okay. Now if I run the line number 29 now, it will not throw an error because we are saying that this is replaced. And if you run the data now, my index column also goes out. Right? Now I have a proper structure on the table. Correct? Did that make sense? It
Yes.
makes sense. Right. So this way I am giving a hint that how we can work on the database. Now you know the database completely. You know the Python completely. Now your job is to work on different theories on the how we can create a view or how I can write a subqueries, subquery out of tables, all the concepts that your job is to work on that. Because I have given a hint how you can work with the database. Now up to here, because here only we need to change something. Okay, make sense? Did that make sense
Yeah.
to everybody?
Yes.
Because that is job of yours to work on different concept of the database from the Python. So let's take you want to understand how you can write a subquery from out of that I want to create a table. Suppose I want to create a view out of the Python. So I'm saying that view is not possible from the Python. Okay, from the pandas you can't create a view as long as I know. Maybe in the current version something has come up. I don't have a requirement for that. Do you can do try whether view can be created on the pandas or anything, any sort of thing, what you think we can to try on the things that you can do. But basically, this is the way you need to read the data, and it could be. It's not like reading data from the CS. Maybe the data will be read from the database itself as well. Okay. So that time, what do you need to use? Instead of read CSV, you need to say read SQL. If you want to use the read the data from the database and you want to write into the SQL as well, then you can say read SQL and to SQL. Both you need to use it. Does that make sense?
Yes, Samir. This is ETL function, right? We are extracting the data
Yeah.
and we are
Yeah.
loading here. And for
Yeah.
extracting, we can get any SQL, Oracle, any other database. And loading in the, we are doing this process in Python or any other language also, right? We are doing Python, but for a common for ETL function, we can do with other language and other database also, right?
That's what I'm saying. Your input could be anything. Your input could be file, your input could be any database, then your output could be any file, and your output could be any database. Doesn't matter. So you know both the steps, how to read the database, how to read the file, whatever your input, whatever your output, just make through that. That's it. That's simple.
Okay, Samir. Yeah, got it. Thank you.
Okay, we are good.
Yes.
Okay. So on that note, guys, I'm done with your like the Python module, like which extensively we discussed. Uh, so I'm not stopping you anything here. So do try it out on your own. Anything on that specific you want to discuss with me, do let me know. We'll do that. Okay. But apart from that, I think we covered the Python basics completely. Class module, advanced Python also we covered like class, object, inheritance, everything we discussed. Then pandas and numpy extensively we discussed, like the database wise everything. So now up to you to how you are practicing, how you are taking it. So I have given a couple of data sources as well. If you want, I can give other data sets as well for your practice. Okay? If that makes sense.
Yes.
Any questions? Any questions, guys? Any questions? Good? Hello?
So Samir, other than these concept in Python, we have to know any other concept, or is it more than enough for
It's
job?
more than it's more than
Okay.
it's more than
Okay,
enough.
sir. Thank you.
Because this is the area we are targeting. So we focus on that because Python is so vast. So we can't like you need to stick to your plan. Like what exactly you want to do it. Other than that, if any requirement comes up, you need to do it. Otherwise, no.
Okay, Samir, got it. Thank you.
And even I will put it in a notepad. If you are, you can do one more on the Python that module. That is called. You can do it on your own. I will help you if you want. Web scrap. This part, just do it using Python. There are some couple of modules will be there. Web scraping in the sense websiting. Suppose you have a website and then I want to read the data from directly to the Python, and based on that I can do analysis. So that is called a web scraping. This is also good part. You can try it out. That is all of your choice. I would say go for it, but based on your time. Okay.
Okay, Samir, got it.
Okay. Any other questions you guys have?
We need to practice little on that what.
Yeah, you need to practice more practice, and don't stop practicing Python because you will forget. Because the continuation will come immediately. Because you are starting now the big data, and big data in the data bricks, the Spark will come, and Spark will write in Python. So if you forget that, it will be a problem. Okay, if that makes sense. So in that sense, start with your the last part of your module is called my is called your big data. So let me go to the what is big data and all these things. Okay. Let me go through a theory portion first. Then I will start a couple of things there. Okay. So what do you mean understand about a big data? Nowadays it is very common terminology now across the industry, across the technologies and stacks and all. Like big
It's
data, big
billion
data,
of,
big data.
yeah, it's billion of records, million to billion of records.
So the thing is correct. That is correct. Like as the name suggests, it's a big data. Big means the amount is very huge. But why it is required? Because day by day the data are getting increased. Okay, and even you want to store the data, you want to process the data, you want to consume the data. All these things we need to do. So just think of a YouTube, right? In a YouTube, in a second, a fraction of seconds, how much data will be getting captured, right? Because across the globe, so many people are watching the YouTube videos, right? Just think like that. If they don't have ecosystem to handle big amount of data, then they can't process the data properly, and you will not able to see the data properly as well. Okay, so every industry is now on the verge of storing the big amount of data. So for that, they should have a proper framework, proper structure, proper mechanism to store the data in a proper way so that we can extract the data and load the data and even consume the data as well. So that is the main agenda of the big data. Okay. Now, so there are couple of properties of the big data. Okay. So the first property which I'm talking about is called your volume. Okay. Second property, sorry. Second property is called the variety. Okay. Third property is called the velocity. Fourth property is called veracity. And fourth property, last property is called the value. So basically, big data is defined with these five V's. Okay. So the volume, variety, velocity, veracity, and value. Let's discuss one by one. The first point is the volume. Where volume means nothing but is the huge amount of data. So it can process huge amount of data. We can't expect. Okay. The amount of data which I'm talking about is like the billions and trillions of data. Okay. And what is called a variety? Variety is something like the data wise. So as of now, whatever you do on the database, when on the Python, everything is a structured data type. Structure in the sense either in the form of a tables, rows, and columns. Hmm? And in the CSV file or with the TXT file also, that is proper structured data. Is there. Suppose think like that, you have a semi-structured file, JSON file, XML file, even what you call the unstructured data. Unstructured in the sense in image file, video files, audio files, all these are for the unstructured data, right? So to handle all this data, big data have the feature to can feature all this, or it can read all the data and it can process the data. So that is called the varieties property. So in this sense, it can handle structured data, the normal one, semi-structure, which is nothing but my semi-structure. It's in the form of a XML, JSON, all these things format, and finally it will be the unstructured. Can handle this unstructured like video, images, all these things. This property is called your variety properties. Any questions up to here? Do you have any questions?
No. No.
Third property is called the velocity. Velocity is nothing but the speed at which the new data is coming in. So the data is flowing very high, and you want to process the data in that speed only. That is called the velocity. Okay, because in a fraction of second in YouTube, I'm talking about, there will be billions of data will be there. Immediately we need to consume it. Immediately we need to process it. Okay, so that the my processing will be faster. Everything should look so. YouTube, there could be any rarely very chances would be there will be latency. Latency would be from our end, the network speed and all. But very rare chances will be there that YouTube had the latency, right? Because it will be process the data immediately, whatever is there. So that's have a proper mechanism. So that's what they are able to do it, right? So the velocity is that like the speed at which the new data is coming up. Okay. Then the last two properties is called the veracity. Veracity is nothing but my quality of data. Okay. And the last one, the value. Uh, this should generate some value. So it's not like that. Suppose you are reading some data, huge amount of data you are reading. That is fine. But after reading, if you are not able to convert to a meaningful information out of that, then reading is waste only. Is why you will read. It's not like big data is not lined up only to read the data on a bulk. No. Yes, the one part is we need to read the data on a bulk, but finally we need to make it in a such a way that it should benefit my company, like information wise, or what exactly this data is all about. So that is for the value. Okay. So this should give some meaningful information. Okay. So this is about the big data. Big data is the 5 B's: volume, variety, velocity, veracity, and value. These are the 5 pillars of the big data which lies on that, and based on that we can work on that. Okay, makes sense.
Yes.
Now, few things. There is another two technology. I'm putting two words there. Okay, which defines the data. Sorry, big data as well again. So there are two types of systems available actually. In a real world. There will be two types of systems. The first one is called your my monolithic. I'll let you know. And second one is called your distributed. Okay. So monolithic and your distributed. What the difference between this? So in the monolithic, what happens is in a single system, all the resources will be there. If I talking about the resources, no, resources means, one second, I will tell you what is resources. If you go to your task manager, you know how to go to a task manager? on your system. If you are on a Windows PC, I don't know about the Mac rather, but if you right click on your taskbar, no, you will get a task manager. So in the task manager, if you see the CPU, memory, disk, and network, this four. This four is called your resources of your system. Okay, CPU, memory, disk, and network. There could be some additional component, but these are the four uh, important components which tell us that if somebody say that what is your resource on your system, that they are referring to the CPU, memory, disk, and network. That's it. Or most probably they are referring to the CPU and your memory. Okay, got it?
Yes.
So in this case, what happens is in the monolithic system, the resources will be on a single system only. Okay, so let's say this is my laptop. All the resources will be available on my system. I want to process it, everything. Okay, so it is not a scalable system. So in a single system, if all the resources will be available, if the data set is very high, it will make some problem. Like there will be some waiting time to process the data. All these things will come up. Okay. So what is distributed system? Distributed system something like is like is a cluster of machines. Clustered of machines, which normally we will get in real time. Clustered machines. Okay. There will be a primary node. Okay. And there could be n number of let me put it in a pen so that you can understand how it will be looks like. Okay. So there will be a primary node here. That is my primary node. And there could be any number of nodes will be there. A1, 2, 3. Let's take 4 node cluster. So all the child nodes, these are the child nodes, are connected to the parent nodes. Okay, so like this. Okay, so here the request will come to here. Okay, and whichever the node is available on that front, that process will goes there. It will be processed. So and each node will be of a high processor, like high resources, like the CPU, memories, all these things will be on a higher side. It will process the data, and this leads to a parallelism. Like parallelism in the sense, uh, processors can be divided. Like multiple process can be run in a parallel, right? So one process is running here, second process run can here, third process can run here, and fourth process can run here, and finally they can give you the output as well. But if it's a single system, everything should be covered up. First process needs to be done, then second process, then third process, then fourth process. There will be some waiting period will come. So this mechanism is called your monolithic and distributed. Why I am discussing all this theory question? Because in the interview they could ask you all this question as well. What is monolithic? What is distributed? Because when you are going for a big data interview. Okay, make sense? Any questions up to here? You guys have
So Samir, in companies they are using distributed only, right?
100%. There will be no single server. Only we are working on a single on your local. Okay.
Okay.
So now let's understand little bit about the history of the big data, how it got started, how things work on all these things, right? So to I'm not going very like older way, but where I will start is that the big data actually introduced as a framework by Hadoop. Have you heard about the Hadoop any time? This word HADOOP, Hadoop. Have you
Yes,
heard
we
about?
heard.
Okay. What is Hadoop? Any idea what is Hadoop? I will
It's
not this. What?
a framework of
Good.
the Java.
It's not a framework of Java actually. It's written on Java, but it's not a Java. So Hadoop is a framework. Framework means what? Yes. What do you mean by framework? I asked this question multiple times in the interview. Like, what is framework? What do you understand a framework? If I write, you
It's
will
a,
not able.
it's a structure of data.
No, it's not structure
Okay.
of data. Others, any idea? What is that? If I not ask this question, I think this you will not ask me that question, right? Framework is a skeleton where multiple features, multiple methods, multiple functionality is incorporated. Okay, it is something like I can give an example of your mobile apps. If you click on apps, we are getting n number of functionality. We can log in. Once you log in, we can have, like, suppose you are putting into a game software, we can have multiple games there. There we can write something, complain about that. We can chat with the customer care, all these features. So it is like a skeleton where all the features are intact. That is called a framework. Okay. So here also Hadoop is a framework. Why this framework got created? This framework got created to solve the big data problems. And it was introduced long back in the 90s only. So there the Hadoop got introduced and to solve the big data problems. Nowadays there is no scope because big data is evolved now. So many things are evolved. We will come to that. But this is the Hadoop. It's the framework to solve your big data problem. This is the first one. Okay. So if I say basically rough into that, previously there are some Hadoop, but actual Hadoop version started in 2007. It was on Hadoop 1.0. The first edition of your Hadoop comes up. Okay. And then in 2012 it comes the Hadoop. Maybe year I will be wrong. Okay, you check it out on this one. 99% I'm right, but still the Hadoop 2.0 and the current version is 3.0. Okay, Hadoop 3. So these are the different versions, they evolve at different times. Okay. So every one more thing, whenever there is a framework of the big data, any framework, there will be three components to it. First is the storage component, second component is called processing component, and third one is called the resource management, like how we are managing the resources. So there are always the three components always works whenever there is a big data is coming up. Okay. So first part is called your storage. Do stop me, okay? Anytime you have a doubt here, okay? Next is called the processing. Third is your resource management. Last part will come later, very late. But this is the way it got segregated. Any big data framework. In this case, in the case of Hadoop 2.0 or even 3.0, the storage part is taken care by HDFS, that is Hadoop Distribution File System. Okay, Hadoop Distribution File System. Okay, and processing will be done through the MapReduce, and resource manager is called the YARN. YARN stand for yet another negotiator. I think. Negotiator. These are the three things. Just there. Okay. Now I have never used the Hadoop 1.0, neither 2.0 because I'm not that old. So the current version I know how it works on the Hadoop. So the thing is, I'll tell you, like, Hadoop is not directly used now. Hadoop is replaced by the cloud technologies now, but the core thing is still on the Hadoop only because without Hadoop, the big data can't survive. Okay, so when I will do the Databricks also store the data in the form of HDFS one because it is storage in the form of the file system only. Resource manager could be different, your processing could be different. Nowadays, these two are not in use only. Processing MapReduce long back it gone. There will be no MapReduce, and even YARN also is replaced by multiple stuffs that we will discuss slowly and introduce it. But the thing is, these are the three important components of any big data system. That is called the storage, processing, and the resource management. Okay. Any questions up to here, guys?
Yeah,
No,
Samir, Hadoop is coming under Azure, or it's a separate one we have to know.
No, it's not comes under Azure. So Hadoop is a framework they created. Okay, so they have some limitation. I'll come to that. So due to that limitation, directly we are not using the Hadoop because Hadoop is work on the Linux. Okay, so you need to install Linux, then you need to install all the tools for that. You need to work on it. It's very difficult. So
Okay.
by that time it got evolved, right? Multiple technology comes up. Like I can give an example of Databricks. So Databricks is a framework. On top of that, it's Hadoop only. Because underlying thing will be Hadoop only. But we no need to write multiple things like that what we are doing in the traditional Hadoop. But what I'm saying is that this is the pillar. Under that pillar, so many things are there. But we no need to learn the basic. Like in the sense, Hadoop is not being used completely. Directly in the command line prompt, Hadoop is not being used. To learn the Databricks, there we will able to understand the Hadoop what exactly is all.
Okay, so
I'll come to
we
that.
have, okay, sir.
Yeah.
Yeah.
It makes sense, right? Somehow.
Yes, Samir.
Okay, so now just an example I'm giving why Hadoop is so in the sense difficult to execute because but when it was there was no alternate. People used to do like that. Okay, so I will give some example. In Hadoop ecosystem or the framework, there are multiple tools are there. Multiple tools. Okay, so one tool, the tools used inside the Hadoop previously traditional Hadoop inside Hadoop. So first tool is what is the pig. So pig is nothing but it's a scripting language. Okay. Just like what you are doing somehow in Python, now, somehow like that one. The scripting language. This is used to clean the data. Suppose you have some data and you want to clean it, then you need to use the pig. There is software under the Hadoop. Okay. Tools. Second, suppose Hive. Another tool is called the Hive. This will provide a SQL kind of environment. Provide SQL kind of environment. Suppose you want to write some code on a SQL kind of way, then Hive will be providing that. Okay, makes sense to query the data. Third, there is a UG. I don't know whether they are using right now or not. UG. UG is nothing but to call the workflow schedule or the scheduler. Suppose something you have written and you want to run the data in a time frame, suppose 8 a.m. PST or 6 a.m. PST or 8 a.m. whatever the timing, then you need to use the UG. Okay, this is all. Fourth, HBase. It is like a NoSQL database, columnar data, which we will discuss in Azure with our Cosmos DB or Azure SQL DB. We'll see that. So HBase. So what I'm trying to say here is that each part is a separate thing. So we need to install it, work on, install it, work on, install it, work on. Okay, this is all things. And one thing which is the main drawback of the traditional Hadoop is called the MapReduce. Because MapReduce, if I show you, sometime maybe next class or after 2 class, I'll show you one MapReduce code. For a simple thing also, if you want to write a MapReduce code, it will be very huge, and it is comes under the Java. You need to write the code in a Java, and the codes are very huge. In a normal, traditional, normal people, right? It is very hard to understand the MapReduce, and it is very lengthy to write it also, and the processing also very slow in case of MapReduce. Okay, where you want to process the data. Does that make sense? Any questions up to here, guys?
Can you just repeat the limitation of storage?
The MapReduce. Okay,
Uh,
sure. So I'll say the MapReduce is very slow, very slow, and it is really hard to write the code also, and it's very hard to write the code. What you are writing in Python, no, it is quite easy. Hard to write the code. Okay. Second problem on the Hadoop is, in this case, this is the first problem. Second is that you need to learn so many things. Suppose you want to write a script, you need to learn pig. You want to work on the SQL kind of environment, you need to learn Hive. You want to work on the scheduler, you need to learn Uzi, HBase. So these are the only 4 components I'm giving. There are n number of components are there. So each component you need to learn, do it, learn, do it, learn, do it. So that's another drawback also. The first problem is we need to learn different things. Okay. And third problem is this on-premise. On-premise means it will store on the local. Okay. There is your traditional server will be there, it will store. It is not on the cloud. Okay. Hadoop is on the normal on-premises. So these are the problems we have in the Hadoop. But whatever developed post to this, whether in a cloud, AWS cloud or in Azure cloud, whatever the develop on the big data, concept remains same. The backbone or the underlying system, underneath system is same. They are giving you a much comfortable way to write the code in a different way. That's where the Hadoop stands. So the backbone or the underlying technology will be same. Okay? Makes sense? Any questions you have up to now?
Some for
Do
the
you have
map
any?
producing you are talking about, right? For the data
Mhm.
science role, you need to know the map reduce.
Now there is no use of MapReduce now
Oh,
in a IT. Zero.
oh, okay,
Yeah.
okay, it's zero now. It's an outdated
Yeah.
now. Okay,
Outdated. Yeah. Yeah.
okay, good.
SDFS storage you are using it. I'll come to that. So processing and resource manager I will replace it.
So
So basically, go ahead.
right, right. My sorry to interrupt. Okay, my question is now it's an outdated what you're saying MapReduce. Suppose they want to migrate, which is the code is already in the MapReduce, they're converting into the different technology, right? In that case,
Hmm.
right?
Hmm.
We want to
So, ha.
how that that's
So there could be chances
okay.
of saying that yes, there could be like there will be traditional Hadoop is there and we want to migrate
Mm,
it to the cloud. Okay.
mm, mm.
That time the cloud there is some APIs will be there. Doesn't matter whether you know Hadoop or
Okay,
you don't know, that will be converted. But
okay.
nowadays 90% is migration is done. Okay. So now
Oh, okay,
we are been to the cloud only almost. Okay. So there will
okay.
be
Got it.
very rare will get it this information.
Okay, got it. Thanks.
Okay, now I will replace, as you know, the traditional any database system, sorry, any big data, three components: storage, processing, and your resource management. Now I will replace this part into the modern stacks, like how this got evolved and which are the storage, which are the HDFCs. Okay, so here first part I'm taking up the modern stacks. So the first part I will replace the storage. Storage still it could be SDFS because few tools got created. They are storing the data inside the SDFS also. There could be a mechanism where you can store as a file system. Okay, I'm agree to this SDFS. Now common stacks would be here in this case is uh, Amazon S3. We can store the data on the cloud. So where you are using your AWS cloud, right? So data will be stored on a S3 bucket. So S3 bucket is nothing but your storage area where you are storing the data. Okay. And if you are using a Azure Cloud Store, then it will be ADLS Gen 2. This is the way it will be replaced. Okay. So if you are Azure ADLS Gen 2, if you are using the AWS, it could be Amazon S3. Okay. So this part could be storage. Now comes to the processing. Processing, as I told, is completely reduced. Now, MapReduce, there is no use at all. Okay. Processing is completely taken over by Spark. That's where your own main focus would be. It is taken over by Spark. Now, that's why the Spark will come up. Spark is nothing but called the processing, where you will process the data, which is replacement, complete replacement of the MapReduce. Nowhere you will find the MapReduce. Spark will be everywhere. Spark. Okay. And the final one, your resource manager. Okay. I not seeing any yarn, but few people are saying that yarn also is in use, but I never saw. Resource manager, I saw the way the modern stack works is replaced by the Kubernetes. Have you heard about the Kubernetes? The words.
No.
Okay, no problem. So this is another tool which will be, it will manage your resources. We'll see that when you go to Databricks. I will show you that all the stuffs. But this is your modern stack is all about. So either you will be on a cloud, S3, or even on Azure cloud, or it could be GCP also, Google Cloud, doesn't matter where you are storing it. Finally, we'll write the code on the Spark to process the data and finally get the output, and the resource manager will work on the Kubernetes. Okay, so our main focus should be on storage and even on the Spark. Spark is very much important for us, okay, because all the things, all the code writing, everything, whatever you want to do, the processing and all, everything will be done on the Spark itself. Now comes to the Spark. Spark can be written on the Spark code, can be written in multiple ways. Can be written in multiple ways. Okay. First way, you can use Python. You can use the Python code. Way you are writing the Python, you can use the Spark code using Python language. Second, you can use the Scala. I'll tell you. Third is called another language which can be used, the R, source R one. And fourth one can be Java. Okay. So what is Scala? Scala is a language. Okay. Actually, the Spark framework which we are using it is written on Scala only. So the when the Spark got developed, it was written on a language called Scala. Okay. But nowadays we are not using much on the Scala because Python is booming up. So we are using Python, and even R Java. Java is not in use at any cost. Few people use the R only, but we are more focused on the Python. And another way we can write nowadays is Python, sorry, in your Spark in traditional SQL. We can directly write the SQL normal way. So we will learn this two one, the Python and the SQL. That's why I am more focused on the first two module, SQL and the Python. Now your learning curve will come into picture because there will be syntax difference will be there slightly, but most of the time 90 to 95% will be same. Whatever you learn on the pandas, data frame, writing the SQL, Python's list, all these things will come into picture. And when you write the Spark in Python, that is called the PySpark. I think there could be a technology somewhere you heard about the PySpark and all. PySpark is nothing but the Spark on the Python. Okay. So this is where we stand. Okay. So from the next class, slightly portion of the theory I left it, I will cover it up. Then we will start the PySpark directly on the Databricks. Like Databricks, I will show you how to connect it, how we can write your Python code there itself, and from there we'll go on. Okay, make sense? Any questions up to here, guys? You have?
No.
Okay, we're good. At least got a slightly picture wise like how it got evolved. At least you have idea. Got some idea.
Yeah, Samir. So
Hmm.
now Spark we are using Python, R and SQL mainly.
No, no, we can use the Scala as well, but companies are
Yeah,
not
not
using.
now. Okay. Okay. And Samir, Java they developed before Python they developed before Java, right? But now Python is more wanted. Why than Java
It's
and any other language nowadays?
But if you Google your history, right, Python is more beyond Java also. Python was booming up now, but Python was
Yes,
there before as well.
yes, yes.
It's not
But
like the Java was the first and sad last. Because of Python of the flexibility.
okay, for
Python
web
was popular.
development,
Yes, everything, not web development. The libraries which they are created, right? That's why Python become more flexible and it can fit to anything. Like database, it fits. Web scrap, it fits. Even on the ML AI light, it fits. So everywhere, it somehow it fits. Okay. And that's why it has become more. That's second. And writing of the code, if you compare the Java to the Python, Python is somehow easy compared to the Java. Okay?
Yes, yes, Samir. Yeah,
That's right.
thank you. Yeah.
Okay, then I think I'm done.